Today we are talking about section 4.2, matrix operations. And the operations that we're going to focus on today are addition and subtraction. So, matrices can be added or subtracted if and only if they have the same dimensions. So if you remember, dimensions were how many rows by how many columns a matrix had. So, for example here, if we wanted to add a matrix A and matrix B together, if A is a 3 by 4 matrix and B is a 3 by 4 matrix, then we can add them. If matrix A was a 2 by 3 and matrix B was a 2 by 4, notice the dimensions are not the same, so this is not possible. Okay, so they absolutely have to have exactly the same dimensions, same number of rows and same number of columns. Otherwise, the addition or the subtraction, whichever one you are doing, is not possible. Okay, the reason for this is because when we add or subtract, we do it element by element. So you can see on here, I have a matrix set up, matrix A, B, C, and D. And if we were just doing plus, matrix E, F, G, and H, then what I do in order to add them is I add each element that corresponds to each other. So since A and E are on the top left-hand corner, then they get added together. Okay, so you can see here in pink, I have the minus. So if I were subtracting these matrices, then they would get subtracted. Okay, so I would have A plus E or A minus E. And then I would do the next one. So up here in the top right-hand corner, C and G. So C plus G or C minus G. Then the bottom left, B and F. And then lastly, the bottom right, D and H. And they get added together. So that is how we do matrix addition or subtraction. Okay, so let's look at an example. So if I had matrix A, which you can see is a 2 by 2 matrix, and inside we have 4, -6, 2, and 3. B is also a 2 by 2 matrix, inside -3, 5, 7, and -9. So since they're both a 2 by 2 matrix, I'm allowed to add or subtract them. So the first one here, we want to find A plus B, matrix A plus matrix B. So what we're going to go ahead and do is, this is the work that I need to show. So I am going to add each element. So I'm going to take the first one, the top left-hand corner. So I'm going to have 4 plus a -3. So you can see I've written that right there. The next one over, -6 plus the 7. Bottom left-hand corner, 2 plus the 5. And then bottom right-hand corner, 3 plus the -9. And then I'm just going to do the math. So 4 plus a -3 is 1. -6 plus 7 is 1. 2 plus 5 is 7. And 3 plus -9 is -6. And so this matrix right here would be my answer. Let's look at an example and see what happens if I want to subtract. So if I want to find matrix B minus A. Now, remember, when we're subtracting, order matters, just like it always has, so we have to be careful. So I'm going to go ahead and use the same matrices I've used up here. Let me zoom out a little so you can see them. So my first one, I'm doing B first this time. So I am taking the top left-hand corner of B. Sorry, trying to get this all in here. Top left-hand corner of B minus top left-hand corner of A. So I have -3 minus 4. I'm going to do the top right-hand corner of B, which is 7, minus A, which is -6. Notice I've been very careful with my signs. Don't mess them up. Okay, bottom left-hand corner of B is 5. So 5 minus 2. And then the last one would be -9 minus 3. And so then I've just gone ahead and done the math. -3 minus 4 is a -7. Anytime I have minus and negative, I get plus. So 7 plus 6 is 13. 5 minus 2 is 3. And -9 minus 3 is a -12. So this matrix right here is my answer to B minus A. Hey, a little more vocab here for you. So a scalar is a constant that is multiplied by a matrix. And remember, a constant is just a number. Okay, and it doesn't matter, it doesn't have to be a whole number or an integer, it can be any number at all. So we could do decimals, we could do fractions, anything like that, just any number that we can multiply by, that we are multiplying a matrix by. The operation of the multiplication is called a scalar multiplication. Okay, so just the number is a scalar, and the operation of multiplying is scalar multiplication. So let's go ahead and look to see what this would look like. So K represents my scalar or my number, and I'm multiplying it by matrix A, B, C, and D. So you can see I'm going to go ahead and I'm going to multiply each element in the matrix by the scalar. So the top one is the scalar K times A, then I have the scalar K times C, then K times B, and K times D. So let's look at an example. So this time I'm going to let matrix A equal a 2 by 3 matrix. So I have 2, 5, 8, -9, -3, and 2. And I want to go ahead and find 3 times A. So I went ahead and I wrote 3 times A. So 3 times my matrix, and I've just multiplied. So 3 times 2 is 6. 3 times 8 is 24. 3 times -3 is a -9. 3 times 5 is 15. 3 times -9 is a -27. And lastly, 3 times 2 is 6. So this matrix right here is my answer, or 3A. So I can do lots of operations with matrices. Some properties hold true, just like when we learned with addition and subtraction, basic things. Some hold true for matrices and some don't. So some of our ones that hold true are the commutative property of addition. So if I add matrix A to matrix B, that's the same thing as adding matrix B to matrix A. They're the same exact thing, and you can see that because we're doing element by element. Also, the associative property of addition still works. So if I'm adding 3 matrices, it does not matter what order I add them in. It's going to all be the same. And lastly, the distributive property. And the distributive property as it applies to a scalar. So if I were to add 2 matrices first and then multiply them by a scalar, that would be the same thing as multiplying each one by the scalar first and then multiplying them. So all of these hold true, and I'm allowed to use them to my benefit as I work through matrices. Okay, so our last example here, let's do one where we have to do many operations. So I want to find 5 times matrix A minus 2 times matrix B, and I'm going to use the same matrices as from my first example. Okay, so I've gone ahead and I've written the matrices in here. So 5 times matrix A minus 2 times matrix B. Now, because I have a -2 in here, there are 2 different ways that I could do this. The first way here is I went ahead, so the first one, I multiplied everything inside by the scalar. So 5 times 4 is 20. 5 times 2 is 10. 5 times -6, -30. And 5 times 3, whoopsie, I made a mistake there, should be a positive 15. So now I'm going to have to fix this as I go because I've made a mistake. So 5 times 3 is a positive 15. Now on the second one, you can see this one is minus, I left it minus. So when I multiplied it by a scalar, I multiplied it just by 2. So 2 times -3 is -6. 2 times 5 is 10. 2 times 7 is 14, and 2 times -9 is -18. So I have a minus. So now I have the 2 matrices here that I am subtracting. So I went ahead and subtracted element by element. So 20, sorry, I've got too much stuff going here. So 20 minus -6, anytime I have minus a negative, that becomes a plus. So I have 20 plus 6, which is 26. Then I have -30 minus 14, which gives me a negative 44. 10 minus 10 is 0, and then I've got to fix this one. Oh, yeah. So then 15 minus a negative 18 minus a negative gives me a plus again. So then 15 plus 18 should actually be 33. Okay, so that one should have been 33. So that's one way you could do it. And so then this matrix would be my answer. The other way you could do it is instead of multiplying matrix B by a scalar of 2 and subtracting them, I could say that scalar is a negative 2. And so I could multiply matrix B by a negative 2. So on my first one, oops, I made that mistake again because I just copied it down. Okay, so on my first one, I just took 5, the scalar 5, and multiplied it by matrix A. So the first step is still the same. The second step, I took negative 2 and multiplied it in. So negative 2 times negative 3 is a positive 6. Negative 2 times 7 is negative 14. Negative 2 times 5 is a negative 10. And then negative 2 times a negative 9 is 18. So now I have, because I distributed a negative 2, the negative went inside, so I'm left with a plus out here. So, oh, my table's sticky. So now that I've done that, I'm adding, so I'm going to go ahead and add. So 20 plus 6 is 26. Negative 30 plus a negative 14 is a negative 44. 10 plus a negative 10 is 0. And then 15 plus 18 is 33. To fix that last mistake I've made there. So you can see no matter what, I've ended up with the same answer, which is exactly what I need to do. So just like always, when you distribute inside, because when we multiply by a scalar, that's pretty much the same thing as distributing inside a set of parentheses. Okay? So just like when I distributed, I could either distribute a positive 2 and then subtract, or I could distribute it as a negative 2 and then add. Either way is the same exact thing, so you can do it either way.